integrator test to check whether the series converges or diverges. For that, we have f of n is equal to n divided by n square plus 1 whole raised to 3 by 2. We can see that for n is positive, n equal to 1 to infinity. This is positive series, and positive is continuous. This is a polynomial type equation, so this is continuous and positive. Next, we have to show that this is n into n square plus 1 raised to 3 by 2 minus 1, that is equal to 1 by 2. 3 by 2 is here, into 2n divided by n square plus 1 whole raised to 3 by 2 raised to 2, which is equal to n square plus 1 raised to 3 by 2 minus 2 get cancelled, minus 3n square into n square plus 1 raised to 1 by 2 divided by n square plus 1 raised to, this is 3. I'm taking n square plus 1 raised to 1 by 2 outside. So this is n square plus 1 minus 3n square divided by n square plus 1 raised to 3 by 2. So 3. This is equal to, again this is n square, this is 1 minus 2n square divided by n square plus 1. This is n square plus 1 into this is square into n square plus 1 raised to 1 by 2. 1 square root to get cancelled. Here n is greater than 1, so 1 minus 2n square is always less than 0. Okay, so f dash is less than 0, which implies f is decreasing. So what we have got, f is decreasing, positive and continuous. So we can apply the integral test. Integral 1 to infinity f of x dx equal to integral 1 to infinity f of x equal to x divided by x square plus 1 raised to 3 by 2 to dx. Put x square plus 1 is equal to t in this, equal to 2. So 2x dx is equal to dt. So x dx is equal to dt by 2. So what we will get? This is equal to limit b tends to infinity, integral 1 to b, x dx is dt by 2, 1 by 2 into dt divided by t raised to 3 by 2. This is equal to 1 by 2 into limit b tends to infinity. This is t raised to minus 3 by 2, t raised to minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1 from 1 to b, which is equal to 1 by 2 into limit b tends to infinity, b raised to, this is minus 1 by 2, this minus 1 by 2 divided by minus 1 by 2, 1 by 2 get cancelled, minus 1 raised to minus 1 by 2, which is equal to, as b tends to 0, the value is equal to, this is equal to what we have got, this is equal to, as b tends to infinity, this is equal to 0. That's a finite value, so the series converges. Okay, next is we have to evaluate this one. Again, we have to evaluate this as in the case of this previous one, right? So Next we are going to do is that is the P series. What do you mean by a P series? P series is of the form summation n equal to 1 to infinity 1 by n raised to p. 1 by n raised to p, that's equal to 1 plus 1 by 2 raised to p plus 1 by 3 raised to p plus etc. where p is constant. Observe that if p equal to 1, the series is of the form harmonic series summation n equal to 1 to infinity 1 by n. Next is the theorem, the convergence of the P series. Convergence of the P series, that is, the statement is that summation 1 by n raised to P converges if P is greater than 1 and diverges if P is less than P less than 0. What happened to this one? P less than 0 will happen to this one. We know that limit n tends to infinity 1 by n raised to p. That is, if p is less than 0, p is less than 0, that tends to what? That tends to infinity. Why that tends to infinity? Sigma n equal to 1 infinity 1 by n raised to p is equal to that's equal to this become n raised to minus p. P less than 0 means this is p greater than 0 minus p greater than 0. So this will be as n tends to infinity and raised to a positive power. So that becomes a very large value, that's equal to infinity. So this diverges. Limit is tends to infinity. So the series diverges. If p equal to 0, what happened? Limit n tends to infinity 1 by n raised to 0 is equal to 1, which is not equal to 0. So by divergent test, we can see that if p less than or equal to 0, series diverges. What happened if p is greater than 0? P is greater than 0. We have to notice that 1 by n raised to p, this is f of n equal to this one, and this is positive series, that is decreasing positive and continuous series. How can you say that? 1 by n raised to p is greater than 1 by n plus 1 raised to p. So we can see that this is actually decreasing. This is actually decreasing in this, right? So this is f of n is greater than f of n plus 1. So f is decreasing. So this is a decreasing positive continuous series. So we can apply 1 to infinity 1 by x raised to p dx. That's equal to limit b tends to infinity integral 1 to b 1 by x raised to p into dx, which is equal to limit b tends to infinity 1 by 1 to b x raised to minus p dx, which is equal to limit b tends to infinity. This is x raised to minus p plus 1 divided by minus p plus 1 from 1 to b. which is equal to limit b tends to infinity b raised to minus p plus 1 divided by 1 minus p minus 1 raised to minus p plus 1. This is equal to 1 by 1 minus p into this is actually infinity raised to 1 minus p minus 1 divided by minus 1. P is greater than 0. P is greater than 0 means P is P is when P is greater than P is less than 0. When minus P is less than 0, then infinity raised to a negative value. That's equal to 1 by infinity raised to a value. So this will become a small quantity and tends to 0. This is equal to 1 by 1 minus p into 0 minus 1. That's equal to 1 by p minus 1. We can check value. So this is converges if p is greater than 1. Otherwise it diverges. If p is less than 1, p less than 1 means 1 minus p is greater than 0. So this goes to infinity. So here p is greater than 1, this is less than 0, this term tends to 0. If p is less than 1 or p equal to 1, this becomes 0 value actually. P equal to this does not exist actually. P equal to, when p equal to 1, what happened to this one? P equal to 1 by x dx. So here this exists only if p is less than 1. So the series converges for p less than 1, otherwise it diverges. So it converges if p is greater than 1. The series converges if p greater than 1 and diverges if p less than or equal to 1. Okay. Next we have to do the problems. Determine whether the series converges or diverges. Sigma n equal to 1 to infinity 1 by n square. Next question, sigma n equal to 1 to infinity 1 by root n. Next is one by n cube sigma n raised to minus pi. Okay, so how will you do this? This is n raised to p. Here p is this one, p is equal to 2, which is greater than 1. So the converges by theorem. This is n raised to 1 by 2. So the series diverges. This is minus 1 power. There is 1 by n raised to 1 point something, that is greater than 1. So the series converges.